So one that I've really enjoyed using a lot is TabPFN, which is a neural network which is pre-trained on tabular data. If I'm if I'm correct, I
Yeah, yeah,
might
yeah.
be saying
You are
that
correct. You
wrong,
are correct.
but okay.
Absolutely. Yeah, I looked into this when you first mentioned it to me because I had not heard of TabPFN before. But TabPFN, so typically neural networks are not good at working with tabular data. And in
Uh-huh.
fact, up until you mentioned this, I was not aware of people using neural networks, deep learning, for tackling tabular data problems. So deep learning, I mean, I wrote the book Deep Learning Illustrated, and I've taught deep learning tons of times. And I had students who regularly, as I was teaching deep learning courses, intro to deep learning courses, they would be interested in tabular applications. And I'd be like, yeah, maybe this isn't, maybe
Yeah,
you can give it a shot, but it's probably not going to be very fruitful. You're probably
yeah,
better off using decision trees, for example, a boosted tree approach like XGBoost instead. But yeah, so deep learning is usually better for pattern recognition, where there's a lot of structure in the data, patterns that can be learned kind of spatially in a way. So it's easiest to understand with machine vision problems. So when your inputs are images or video, there's a lot of spatial patterns that deep learning algorithms are adept at being able to tease out what the most important signal is from amongst all of that noise going into the model. And a similar kind of thing ends up happening with natural language processing, which deep learning has also proved, as we can see with the large language models that use deep learning under the hood. Well, that are it's not even under the hood. Fundamentally, large language models are deep learning networks, and so in either yeah, so in with natural language processing, with machine vision, we see amazing, powerful real world applications in machine vision and in generative AI, for example. But tabular data, where the rows are typically, they're not necessarily related to each other in the way that the pixels in an image are or the words in natural language are. And so, yeah, up until you mentioned TabPFN to me, I wasn't aware that somebody had come up with a way of doing neural networks effectively on tabular data. So it's really cool that you found that. I'm really glad you brought it up. And yeah, you probably have more to add.
yeah. I love TabPFN. It's limited, so it's limited on the number of feature columns you have, as well as rows. But so is my data. You know what I mean? My training data is not massive, so it it's actually great at ensembling with other algorithms to either to kind of hone them in to be more accurate. I have found so that as an ensemble has been pretty eye opening, and the fact that it's like instant. TabPFN is like literally takes like half a second to train, and then yeah, and to make an inference. It's super fast, mind blowingly fast.
Yeah, I guess with the relatively small amount of data points that you have, it's not like with the other approaches, like when you're talking about doing the boosted trees and particularly using the grid search CV method
Yeah,
out of the model selection module of scikit-learn. When you do a kind of grid search like that, you're going to be running so many different models. It's going to take a long time. The cool thing about deep learning, and part of what makes it so powerful, is that it allows for features to interact with each other in all kinds of crazy nonlinear ways. And so it's kind of like it's like you're running lots of experiments on, especially how nonlinearities and interactions relate to your outcome in a deep learning model. So it's cool to hear that it's so efficient on the relatively small amount of data in TabPFN, and it doesn't surprise me that that's the case.